All right, this is your geometry 1 through 70 review for your test. There's 30 questions here. Everything on your test is covered in this review. There might be different questions from the same lessons or same questions but with different numbers, and maybe even a number of them that are the same questions, same numbers, but in different orders. So you want to pay close attention to how these things are being worked out and what's expected. Several of these questions we've probably gone over in other reviews and certainly in other lessons. So fast forward to a particular question if you happen to need something more than something else. I just got out of track practice, so I'm going to be a little out of breath, and I've got things to do and places to be. So try to get through this quickly. So if you have to rewind it, go back to what you need to see. Question number 1. Equations of 4 lines are given. Identify the perpendicular lines. Perpendicular lines tells me that their slopes are going to be opposite reciprocals. So I'm going to be looking to put things into slope-intercept form if need be, but I'm looking at things with opposite reciprocal slopes. First thing I'm going to point out is that y equals -8 is a horizontal line. Okay? And I'm going to see down here that x equals 3 is vertical. And just like the y-axis and the x-axis meet at a right angle, so does y equals -8 and x equals 3. So lines 1 and 3 are perpendicular to each other. Okay? Horizontal and vertical lines are perpendicular. That's what I would write. I'd write horizontal and vertical lines are perpendicular, pointing out which one's horizontal, which one's vertical. So the next question comes up is, what are lines 2 and 4? Are they opposite reciprocals to each other? Well, line 2 is already in slope-intercept form, has a slope of 1/3. So in order for line 4 to be perpendicular, it has to have a slope of -3. And if we look through here, we got y minus 5 equals -3x plus 9. We're going to add 5, and that's going to finish off the equation. But we pretty well already knew it had a reciprocal slope from the beginning, because we knew when we distributed that -3 to that x that we were going to get that. We're finally getting 14. So I'm looking at -3 and 1/3 being opposite reciprocals. So lines 2 and 4 are perpendicular as well. So 1 and 3, 2 and 4 are perpendicular. All right, and that's the work we want to show. All right, let's scroll down here to number 2. It says find the distance from P, which is -4, -3, to the line y equals -1. So the shortest distance from a line to a point not on that line is a perpendicular line. So fortunately, this line is horizontal, which means that the perpendicular line is going to be vertical. So we can just count 1, 2. Okay, the distance there is 2. Right? You could also look at the distance between -4, -3, and -4, -1, and see that that's 2. Okay. All right. So it's really more of a matter of counting whenever it comes to a horizontal or vertical line and looking at that. But the other way that I would look at this is the difference in the y values. Okay. So I would look at the difference between -3 and -1. And say the absolute value of -3, let's see, minus -1, okay, which is going to come out to this, is -2. The absolute value of that is 2. All right, so this right here is the work that really works best for that. Okay, it shows the most understanding of what's happening. All right, number 3. Write the similarity statement comparing the 3 triangles in the diagram. Okay, when I have a right triangle with a perpendicular line going from the the hypotenuse to the opposite vertex, see that that's perpendicular. What I've created is 3 similar right triangles. So we're going to look at this in terms of F, G, J, and we've got the smaller one, which is this guy right here, okay, and we're going to find his right angle, which is right there, which we're going to put at H, okay, its long side is G, and it's going to come out to F, and we have our smallest triangle, which is this guy right here. Okay, his right angle is also H, but his long side comes up to F, and the short side goes out to J. So what we're seeing in this is triangle G, F, J is similar to triangle, should be G, H, F, is similar to triangle F, H, J. That is our answer, but you'll notice that that picture really helps show that. Okay, I'll put our right angle there. So we're seeing everything oriented the same way. So I'm comparing G to F, F to H, J to F to J. Okay, all right. So close that out and we'll scroll on up to 4. Okay, 4. Let's scroll over here. Solve for Q in the equilateral triangle. That's the most important phrase in here is equilateral. Because if it's equilateral, then it's equiangular. And if it's equiangular, that means all angles measure 60 degrees. So we're saying Q plus 25 equals 60. We want to solve for Q, so we're going to subtract 25 from both sides. Q is equal to what I believe is 35 degrees. Okay, Q equals 35 degrees. Okay, number 5. Find a point of tangency or write the equation of the line tangent through this point. Okay, so our point of tangency is B. Find a point of tangency. Okay, so point of tangency is point B. Okay, which is at coordinate 1, 2, 3, 0. Okay, but we also want to write the equation of the line tangent through that. So that's this line right here. All right, well, notice that it's a vertical line, and vertical lines are denoted by x equals. So then we're going to find the x coordinate. X equals 3. X equals 3 is our equation of our tangent line. You want to write that out, but I'm going to just keep it short like that. So point of tangency, not just pot, but point of tangency is point B, coordinate 3, 0, and the equation of the line is x equals 3 for our equation of tangent line. 6. Okay, find the volume of the triangular prism. This is one a lot of people make mistakes on because our formula for volume of a prism is the area of the base polygon times the height. People really struggle with the base polygon. They assume the base polygon is whatever's on the bottom. The base polygon is the side that is that has a parallel side. So the sides that are parallel to each other are the triangles. This is you think about it as a triangular prism that's fallen over. It should be, the top and the bottom should be the triangle. So in this case, because the triangle is the base, we want to find the area of the base polygon. That's found by finding the base times the height divided by 2 times the height of the whole prism. So this small b is this length right here, and that small h is this line right here. Now, the big H is that line right there. So we have 8 times 3 divided by 2 times 15. Well, 8 times 3 is 24. 24 divided by 2 is 12. 12 times 15. I want to double check here. Let's see, 12 times 15. I should get 180 meters cubed because we're looking for volume. So that's our volume of our triangular prism. A lot of mistakes that people make there are taking, 8 times 15 for the base and then multiplying that by 3, and it just simply does not work. Okay, because it's not a rectangular prism. Okay, let's go down to number 7, which is crossed over here. Verify that NQ is parallel to PR. We've seen this before. All right, we're going to put NP. Okay, NP over, let's do PM. Okay, so we're going to keep this side over this side. It's going to be equal to 16 over 12, which is going to be equal to 4/3. And if NQ is parallel to PR, then QR over RM which is 8/6, will be equal to the same 4/3. In this case, it is. So since NP, and this goes on with the rest of the question, or the rest of the answer, since these two are equal to each other, they're proportional, they're equal, then NQ is parallel to PR by the converse of the triangle proportionality theorem. Okay, that's not CPCTC. It's just I don't have room to write it all out. I'll read it again so that you can write it out as you come across this. Hopefully you are listening and not just writing things down. You're going to get a long gap in here. Converse of the triangle proportionality theorem. Okay, let's come on to number 8. And I do like volume questions. Find the volume of the cylinder. Use 3.14 for pi. Round your answer to the nearest tenth. A cylinder effectively works the same way as our triangular prism. It uses the same basic formula, except without the base times height divided by 2 times height. In this case, it's still area of the base polygon times height, but the base polygon has a different shape. The base polygon here is a circle, which means in order to find the area of that, we have to do pi r squared and then multiply it by height. So we're going to use 3.14 times my r, which in this case is 4 squared, times my height, which is 10. Let's go ahead and pull up our graphing calculator so you can see all this worked out. Okay, move you guys over here. 3.144 squared 10. Okay, I get 502.4 feet cubed. That's our answer. 502.4 feet cubed. Okay, that's our answer right there. All right, get our calculator out of the way there. All right, let's go on down to number 9. Write the vector of AB in component form. All right, so what we're looking for is this form. Okay, so we're starting from A and we're going to B. I have to do this in order, so I have to do my left and right movement, then my up and down movement. So from A, I'm going right, so I'm using a positive number. So I'm going right, 1, 2, 3, 4, 5. Okay, but then I'm going down, 1, 2, 3. So it'll look like that. And of course, we won't include the plus sign, but we will the negative sign. So we should have in vector component form is our 5, our component -3. Okay, we're approaching the 1/3 mark. Let's look at 10. Oh gosh, get out of the way. All right. All right, 10. AD, this length, this line right here, AD, is tangent to circle A. Find a measure of CAD. Okay, let's use a different color here. CAD. Now we know that this is 132 degrees. So in order to find this, we're going to take 132 and divide it by 2. All right, 132 divided by 2. Okay, we should get measure angle CAD equals 66 degrees. 66 degrees. All right. Close that out. We're 1/3. Let's keep moving. Okay, number 10, give the sine, cosine, and tangent of angle B. All right, so we're using this guy right here. They've given us all the measures. We need to remember first that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now let's set up those ratios based upon this. All right, I'm going to help you out here. This is opposite to that to angle X. This is adjacent to angle X. That is always hypotenuse because it is opposite my right angle. All right, so opposite to X is 33. Hypotenuse is 65. That does not look like it's going to reduce. It'll stay just that way. Adjacent is 56 over 65. Again, that does not look like it'll reduce. And then finally, opposite over adjacent, 33 over 56. Okay. 33 over 56. right, so that appears to be all of number 11, our sine, our cosine, our tangent. Just make sure that you label these things. A lot of people are getting things flipped upside down and backwards. They're getting adjacent over opposite. All right, we really want to make sure that we're doing a good job identifying what opposite is. Opposite is the side that does not share a vertex with our angle, okay? Hypotenuse is always the hypotenuse. Of course, adjacent's the third side after all of that. All right, we'll keep moving here. That's number 11. Let's go on to 12. In kite PQRS, OP, let me read that again. QPO is 50 degrees. So I'm going to come in here. I'm going to say that's 50 degrees. And QRO, this guy right here, is 70 degrees. We want to find PQR. We want to find this guy, this whole thing right here. Okay, what's nice about this is that even though it looks like two triangles, it's still a single triangle in its own right. And that single triangle still has 180 degrees, right? And that whole angle there is whatever's left over after 180. So you can add up 50 and 70. I think you're going to get 120 degrees. I gotta make sure I get that right. Yeah, 120. So 180 minus 120 should be 60 degrees. And so let's check our handy dandy paper over here. Measure angle PQR equals 60 degrees. Okay, we are good. All right, moving on. Okay, this seems to be a very similar question of our very first one, or one of our earlier ones. Equations of four lines are given. Identify the parallel lines. Okay, parallel lines are lines that have the same slope but a different y-intercept. You'll notice that two of these are already in slope-intercept form. 1 and 3 are already set up. So the only things I really have to change are 2 and 4. Okay, let's see. So let's look at 2. I need to move the x 6. And then normally if we see a whole number in front of y, we would divide the entire right-hand side by that. But because it's a fraction, sides by 5 over 1. Because we can't divide by a fraction, but we can multiply by the reciprocal. So y actually equals negative 5x minus 30. Okay, negative 5x minus 30. Well, that tells me something here, that negative 5x and negative 5x, boom, they have the same slope. Those two lines are parallel. Now, it doesn't mean that 1 and 4 aren't, but if I look at this, you know, I'm going to distribute that 4 across these. I'm going to get y plus 9 equals 4x minus 12, and I know I'm going to end up subtracting 9, but I already know the slope to be 4x, which is not parallel to 1/4. It's not parallel to negative 5. So in short, line 2 and 3 are parallel. And the only two in there that are parallel, lines 2 and 3. Okay? Okay, and we verified that. So at the very least, you see this on the test, you would need to at least show me line 2. And if you can indicate to me why line 4 doesn't match up with anything, okay, that would be a benefit too, unless your multiple choice answers are only giving you one single set of pairs. All right, now this may be one of the tougher questions. I don't know that this is on the test. I don't think it is, but it could be. All right, I'm going to pause here for a second while I get a drink. All right, and by drink I meant a drink of water. All right, let's see. Number 14, Michaela's car stereo gets her favorite radio station when the car is no more than 4 kilometers from the station's transmitter. Michaela's driving on Interstate 5, which is represented by the line, which is y equals 2x plus 7. All right, you'll see that it has a y-intercept of 7. It's going up positively, so that makes sense. And each unit represents 1 kilometer. Now, the transmitter is at point T, representing by 0, 0 to the nearest tenth of a kilometer, how far is the transmitter from Interstate 5, should be able to pick up the station. All right, so we need to find the distance from T to that line, and if you remember, one of the things that we said is that the shortest distance from a line to a point not on that line is a perpendicular line. So what we're going to do here is we're going to find the line that gets from here to here. Okay, and we want to find the coordinates of that line, and we're going to find the distance from this point to this point. So we know, let's use this. We know that we're going to have y minus, and we're going to use the coordinates of 0, 0. Okay, so we know y minus 0 equals, all right, then we want to use our opposite reciprocal slope to 2x, so that's negative 1/2 x minus 0. Okay, so that's giving me, y minus 0 equals negative 1/2 x, and that's just it. So I'm not adding anything, so eventually, really what I'm getting is y equals negative 1/2 x. All right, so now that I have that, and I don't think that was super hard to get, okay, we're going to take our new line, and we're going to set one side of each of these equations equal to each other and solve for x. So negative 1/2 x should equal 2x plus 7, and that's going to give me the x value of where they cross right over here. Okay, so let's see, where I have this, and I would, we're going to add, hold on a second, I got to think about this for a second. Okay. We're going to subtract 2x to this side. We're going to get all our x's together. And I think I can erase that out of the way. All right, so we have negative 1/2 minus 2, so that's negative 2.5. Okay, so you can write it up as negative 2.5. I want to say that that's negative 5/2. So negative 5/2 x equals 7. And here I would multiply by the reciprocal to solve for x. Multiplied by negative 2/5. Negative 2/5. It's giving me an x value of x equals, I believe, negative 14/5. Which if you plug in your calculator, you find out what that is. Negative 14 divided by 5 is negative 2.8, which makes sense x-wise where we got that. So we have an x value of negative 14/5. Now, we still have to find a y coordinate in this. Okay? So all we have to do is take our original equation, which was y equals, what do we have? Negative 1/2 x, and plug in negative 14/5 and see where their y value crosses at. So we have negative 1/2 times negative 14/5. So, let's see. I'll plug this up so you guys can actually see it. Okay. Clear that out. Negative 0.5, I'm going to use that for negative 1/2, times negative 14 divided by 5, because I don't know that decimal. Okay, negative 1.4, okay, which is 7/5. Okay. Okay, so y equals, let's see, what do we say, 7/5? Let's see. Where did I get it over there? I'll do it again. Negative 0.5 times negative 14 divided by 5. 1.4 comes out to 7. This 7/5. Okay, which makes sense because we're above the x-axis. So that is the coordinate, and somehow my stuff got moved. If I can move it back, we'll try to do that. Move it back right there. So what you're seeing is that this coordinate right here shows up at negative 14/5 and 7/5. We have to find a distance from that to 0, 0. Okay? Well, because it's 0, 0, right? What we're winding up with is a situation where I have, 0 minus negative 14/5 squared, in the distance formula. Something like this, plus 0 minus 7/5 squared. So really what I'm doing is I'm taking the negative 14/5, or the 14/5 squared, and adding the 7/5 squared, and that's going to give me my distance. Okay, so I think we can do that all as kind of a single thing. All right, if I look in here, let's hit second, let's get our square root, and we can do the whole thing if we want, minus negative, let's say 14 divided by 5, hopefully this will work, plus 0 minus 7 divided by 5, nope, delete, squared, and we'll close up the parentheses and hit enter. Evidently didn't work. All right, so let's try it again. Evidently there's a misuse of parentheses, so let's do 0 minus negative 14 divided by 5 squared plus 0 minus 7 divided by 5 squared. Try this one out. No, still not working. All right, so let's consider this. All right, we know that 0 minus negative 14/5 squared is going to be 14/5 squared, right? It's going to be 0 plus, and 0 is not going to add anything to it. And negative 7/5 squared. So if it makes it any easier on our calculator and we don't have to worry so much about our parentheses, let's try this. Square root of 14 divided by 5 squared plus negative 7 divided by 5 squared, and hit enter. Looks like 4.76, and I'm looking to where, let's see. All right, I think I did something wrong in the calculator. We're going to try this one more time. Now, this tells you how kind of tricky this question can be. Sometimes calculators can be a little tricky too. 14 divided by 5 squared plus negative 7 divided by 5 squared. And we're just not going to do a second set of parentheses. I still get 4.76. And definitely whenever I did it in my own calculator, I got 3.13, which is what we should get. And I don't know why it's not coming out to that. All right, I'm going to try one more thing here and see if I can figure out. Some of the times this old calculator, I'm going to do a second set of parentheses in here, 14 divided by 5 squared plus negative 7 divided by 5 squared, and close up the last outside. There we go, 3.13. 3.13, or even just 3.1 kilometers is what we get out of this. Okay, and so let's go back to our original, let's go back to the reading of what it says, because we actually solved our distance in this. Again, let's kind of slide this back over. We see it the way it should be. Okay, is that it said that the transmitter would transmit how far? When the car is no more than 4 kilometers away. So we're only 3.1 kilometers away. So will she be able to hear it? We're going to say yes. Okay, yes, she can hear the station. So it's a lot of work to get there. So. Okay, let's go down to 15. 15 is using geometric mean, find x, y, and z, express your answer in radical form. And some of these are easier to find than others. Let's see, let's look at this. Let's start off by finding x. In this case, 5 represents a geometric mean. because it's the altitude, so we put 5 here and here, and it's the altitude of the segments of the hypotenuse. So the segments of the hypotenuse are 10 and x. So I'm getting 25 equals 10x. I'm going to divide by 10. I'm going to get x equals 2.5. X equals 2.5. So that's how we're going to find x. Okay, so that's our work for x. Okay, we're going to write 2.5 there if you please. All right, in order to find y, let's see, I'm trying to remember what to do here. Let's see. In this case, okay, if you look at y is a geometric mean to the segments, let's see, I believe it is the segment closest to where we're at, which in this case is 2.5, and the whole. I think you end up with 12.5, which is those two links added together, and 2.5. So just the segment closest to this. So the whole and the segment. So you end up with y squared, and I got to remember, I got to see what 12.5 times 2.5 is. I get 31 and a quarter. Okay, 31.25, 31 and a quarter. Okay. All right, and then we have to square root that. Okay. Well, one thing I want you to remember is that this is 31 and 1/4, right, which is the same thing. Okay. If I take 4 times 31 plus 1. 4 times 31 plus 1, which is giving me 125 over 4. So I am square rooting this, in turn I am square rooting this. Okay? Well, the square root of 125 is, let's see, I believe it's 5 radical 5. The square root of 4 is 2. And I'm going to show you the 125 portion. So if we take 125 divided by 5, we're going to get 25. We're going to get 5 and 5, and I can only take 2 5s out, which is why I got this one, and I got to leave 1 5 in, which is why I get this one. So y equals 5 radical 5 over 2. Okay, and that's how I get that guy right there. Okay, and you're going to solve z the same way. Now, you could solve z, and I wouldn't have anything against you if you did, if you took y at 5 radical 5 over 2, and you had the hypotenuse at 12.5 and found z. But let me show you the geometric mean for solving z. That's going to give me z in z, and then I'm going to take that 12.5, except instead of using 2.5, I'm going to use the segment closest to z, which is 10. So 10 times 10 times 12.5 is 125 equals z squared. So we square root this. And fortunately for us, we already know that the square root of 125 is 5 radical 5. So z equals 5 radical 5. I guess I didn't really need to write it a second time, but those are your 3 answers using geometric mean. All right, 15, we're halfway there. We got 16 right across the way. It's an isosceles triangle. One of the things I know about isosceles triangles is given the congruent sides that the angles opposite them are equal to each other, okay? And in a triangle I only have 180 degrees, so we can take 180 minus 46, okay? Let's see, that should be something like 134. 134 degrees plus 46 is 180. And then that 134 degrees has to be split between those two sides evenly. So we can divide that by 2, and we should get, I believe, 68. But I'm going to check 134 divided by 2. Oh, I was wrong, 67. So n equals 67 degrees. Okay, 67 degrees. That's 16. Let's come down to 17. 17, we've seen this one before. These are all 45, 45, 90 triangles. In a 45, 45, 90 triangle, Okay, if this is my right angle and these are 45, 45, then these two sides are congruent to each other, and this side is, that's those sides times radical 2. So here I got these sides are equal to each other, so this is a 3, and this side is a 3 radical 2. Okay, here this side and this side are equal to each other because this side or this angle and this angle are 45 degrees, which means this side is 3 radical 2, which means my hypotenuse here is 3 radical 2 times radical 2. Well, radical 2 times radical 2 is 2, so 3 times 2 is 6. So this whole length here is 6, which means that guy is just 3. All right, so this means this is x, and that's x, so I got to take 3 divided by radical 2 to find x, but I have to multiply by radical 2 over radical 2, so I get a real answer there. So I'm going to get 3 radical 2 over 2 4x. 3 radical 2 over 2 4x. Okay, that's 17. Okay, all the lesson numbers are down at the bottom of the page with the answer key, and you should find the correct answers to go with all of this. Find the area. We've seen this on our last test. Area of a triangle is base times height divided by 2, irregardless of the orientation. So I make this my base. I make this perpendicular line my height. It's easy to count what I need to count. I can see 1, 2, 3, 4, 5. For my base, my height is that perpendicular line from the base to the opposite vertex. 1, 2, 3, 4. 4, 5 times 4 divided by 2. 5 times 4 is 20. 20 divided by 2 is 10 units squared. I know I'm going through that quick, but you've seen it before, so I don't spend a lot of extra time on it if we don't have to. Number 19, AB and AC are tangent. Tangent lines on a circle that come back to a common vertex are congruent to each other. You guys have seen this on your last test. So we're going to set 3y plus 4 equal to 11y. Solve for y. All right, we can subtract 3y minus 3y. We'll get 4 equals 8y. A lot of people make the mistake of dividing by 4 when we should divide by 8. 4 divided by 8 is 1/2, but be careful that you don't write 1/2 as your answer because it wants to know what is the length of AB. Fortunate for us, we really don't have to do 3 times 1/2 plus 4 because AB is congruent to AC. We can simply write 11 times 1/2. We know we're going to get 11 halves out of that, which is the same thing we would get if we took 3 times 1/2 plus 4. 3 times 1/2 is going to be 3 halves. 3 halves plus 4. 4 would be 8 halves. So 3 halves plus 8 halves is 11 halves. You get the same 11 halves no matter what way you do it. All right, number 20. Number 20, compare the volumes of the cylinder. You saw this on your last test as well. All right, again, volume of a cylinder is pi r squared times height. They don't care how you do it, but make sure that you notice a lot of times they'll throw in a diameter part. So down here, they don't care if you're solving in terms of pi or not, so you can just solve it in terms of pi. Pi times 3.5 squared times my height of 3. Okay, take my calculator. 3.5 squared is 12.25 times 3 is 36.75 pi meters cubed. Okay, and it doesn't matter as long as I do the same thing over here. Okay, we've got pi. I'm going to take 5 divided by 2, which is 2.5 squared, times 6.5. Okay, so 2.5 squared is 6.25 times 6.5 is 40.625 pi meters cubed. Okay, so what I should get in here, and I'm on a whole different sheet now. What are we on here? Question 22. Cylinder Q. Cylinder Q. We were right, had the largest volume, and I feel like I've missed some questions. If we're at 22, I'm going to double back up here and see if I missed. Yeah, I sure did. We missed number 20. So let's find number 20. Seen a question just like this, well, similar to it. The last one asked for volume. This asks for surface area. Surface area is the area of all sides. We have 1, 2, 3, 4, 5 sides. We got 5 sides. You could find the area of all sides, all 5 sides, and add them up. You got 1, 2, 3 around, and 2 bases is 5. But surface area of a prism is perimeter times height plus 2 times the area of the base polygon. So let's do that. Perimeter around the base. Boom, boom, boom. All right, we have 15. Okay, 15 plus 25 plus 20 is going to give me my perimeter. Okay, 15 and 25 is 40. 40 and 20 is 60. Okay, so we're taking 60 times our height, which is actually this 30. Okay, perimeter times height, 60 times 30, I believe it is 1800. 1800 plus 2 times the area of the base polygon. All right, well, because this is a right angle, 15 and 20 make perfect bases, or bases in height. So 15 times 20 divided by 2. 2 times the area of the base polygon. 2's kind of cancel out there. 15 times 20. Okay, so I mean you could multiply that by 2, but you're going to end up dividing by 2. So if we divide it by 2 for just the area, we would get 150, and we end up multiplying it by 2 again, and we'd get 300. So we're going to get 1800 plus 300, which is going to be, in our case, 2100 centimeters squared. Okay, not as easy as it looks. There's a lot of steps involved there, a lot of places to make mistakes. Slow down, take it easy. Make sure you're watching what you're doing, you're writing down your formula right. Make sure you understand all the different parts to that formula. Find NP, right? So we're just trying to find this little length right here. All right, NP over NM, right? NP over NM. That's going to be NP over 5, because NM is 5. Is going to be the same as QR2 is going to be proportional to 2 over 8. All right, so you can make this x if you want. You're going to get 8x equals 10. Divide by 8. You're going to get x equals 5/4. Okay, or let's see, 5/4. They want it as a decimal. X equals 1.25. Okay, so NP equals 1.25. NP equals 1.25. They are proportional line segments. Okay, we already solved 22 down here, all right, because we skipped down there. All right, let's come to 23. A lot of people are getting this wrong. At least they did on the last test. All right, we have to find the average. If we want to find these angles right here, which we do, we're going to take these intercepted arcs, and we're going to add them up, and we're going to divide by 2. This is the average, because these two angles are congruent to each other because they're vertical. All right, so we have to find the average of their intercepted arcs, because if that was a central angle, they would equal these things, but they're not the same. So that's part of our problem. So 148 plus 136 is 284 divided by 2, which should be, I want to say, 142 degrees, which matches up with the fact that they're obtuse angles. Divided by 2, 142 degrees. Match our paper here, 142. So we're going to say measure angle BPD equals 142 degrees. Okay. 24. A jeweler creates a triangular earring by bending pieces of silver. Each earring is equilateral, meaning all sides are the same length. Each side of a triangle is 2 centimeters long. How many earrings can be made from a piece of wire that's 210 centimeters long? Well, all they've done is there's 2 centimeters, there's 2 centimeters, there's 2 centimeters. So each earring, if you were to stretch it back out, is 6 centimeters long. So if I want to know how many earrings I can make out of 210 centimeters, I'm going to divide by 6. 210 divided by 6 comes out to 35 earrings. Okay, 35 earrings. Okay. 25. Identify the following as a translation, rotation, reflection, or none of these. All right. It is a reflection. Okay. And 25, that's all we need. All right. I prefer if you can identify the approximate line of reflection, but reflection is all the answer that's necessary. Okay, 26, we're getting into a trick question. We want to know what R is. It gives you a whole bunch of information. Everything that it's giving you is shown right where we're at. We want to find R. So the first thing I'm going to do, this is opposite, this is hypotenuse, this is adjacent. I have to use the information it's given me to find a piece of information I don't have. So I'm not going to use adjacent. I'm not going to use information I don't have to find something I also don't have. So I'm going to use opposite and hypotenuse. So I'm going to use the sine function. Sine is opposite over hypotenuse. I'm going to put 15 because the next thing that goes up is my degree. Opposite over hypotenuse is 2.8 over r. I need to solve for r, so I'm going to multiply by r. That's going to give me r sine 15 equals 2.8. I'm going to, so I'll rewrite that so you can see it, r sine 15 degrees equals 2.8. In order to solve this, I need to divide by sine 15 degrees on both sides. Okay, so what's going to go in my calculator is 2.8 divided by sine 15 degrees. Okay, again, make sure your calculator is in degree mode or it won't come out correctly. Okay, we're going to check our mode real quick. Mode is in degrees, great. 2.8 divided by sine 15. Okay, we get 10.8. They want it to the nearest, I believe they say nearest hundredth of a foot. So we're going to say 10.82 feet is the length of that ramp. Okay, 10.82 feet. Okay, nearest hundredth of a foot. All right, 26. Let's come back up here to 27. Go back into our kite stuff. So expect to see some kites. Heath is making a kite. He needs to cut 2 wooden rods. So we need to find the length of this and the length of this, and we're going to add all of that together. All right. We should note that if this is 5 here, then this is going to be 5 over here. So I can find the length of BX by finding the Pythagorean theorem. Now, fortunate for me that this is 4 and 5, so I know this is 3 because it's a 3, 4, 5 Pythagorean triple triangle. So I know BX is 3. This length over here is 10, right? Of course, we know this is 10 over here too. So it's the same length. So if I know that I have 4 and I know I have 10, all right, we might do 4 squared plus b squared equals 10 squared in order to find, xd, to find the rest of that length. Okay. The other thing we know to be true is that this is 4 over here. Okay, so I know that one whole length, one whole rod is going to be 8. Okay. So let's go ahead and do this. We got 16 plus b squared equals 100. Okay, we're going to subtract 16 from 100. B squared equals, let's say 84. All right, so we're going to get b equals square root of 84. Okay, we could probably take 84 and reduce it on down, but let's, for sake of time, okay, let's see, what answer are they looking at here? All right, they're looking for an approximate. So let's take 8 plus the square root of 84. Okay, and I got a very different number. Oh, okay. All right, the one thing that we have that I forgot about is that this length is the square root of 84. Right? We also need to add 3 to this, that bx, plus 3. So I should get 20.2, about 20.2. So we're adding all that together, 20.2 inches. Okay, 20.2 inches. Just a few questions left and we're all done. Believe me, it hurts me more than it hurts you. All right, convention center, shape of a rectangular pyramid. Okay, with a height of 464 yards. Its base measures 556 yards by 539 yards. Find the volume of the convention center if necessary. Round your answer to the nearest tenth. All right, so we have something relatively looks like this. Okay, so we have to go back. We've got to remember our volume formula. Let's see, volume should equal the area of the base polygon times, let's see, our altitude divided by 3. So if we're 556 by 539, we're going to have to multiply those things together to get my B. And they tell me that my altitude is 464. 464. All right, so everything that we're going to get right off the top here, okay, can kind of all be done together, okay, but you do have to know your formula. So we're going to do times 539, okay, so this is my big B, times my 464, okay, my height divided by 3. I'm getting a huge number here. Let's see if I'm anywhere near. The answer that they list here is 46,351,125.3 yards cubed. I think we got it exactly. 46,351,125.3 yards cubed. So length times width times height divided by 3 if you want to shorten it down that far. Okay. All right, 29. Use the trigonometric function to find the exact value of x. Right. If we've got this guy, we want to label this. He is opposite. This is hypotenuse. So let's use sine. We're going to use 45 degrees equals x over 40. This is nice because I just need to multiply both sides by 40. So I can just simply write into my calculator 40 sine 45. And that's going to tell me what x is. All right, let's find that. 40 sine 45. Boom, 28.28. Now they're saying 20 radical 2 for their answer. Oh, I see why. Okay, so this isn't the only way to find this, and I'll explain. I think both our answers are correct. Let me pull up that graphic calculator and show you what 20 radical 2 actually looks like. Okay, it should be, notice it's exactly the same. All right, so, 28.28 is the same as 20 radical 2, but let me show you why they get the answer that they do. What they did, and I'll do this in red, is that they look at this as a 45-45 right triangle, which with a hypotenuse, so x to x radical 2. So if we take 40 divided by radical 2, then I'll get radical 2 over radical 2. I get 40 radical 2 divided by 2, which simplifies to 20 radical 2. Okay, so 28.28, okay, whatever else it is, it's the same as this. Okay, and because they said exact value, this number right here, that is an estimate. We're never going to get exact, so that's why they want square root answer there. Okay, so I'll try to remind you or put a note. If you see a question like this on the test, I'm going to tell you that this needs to have a radical in the answer. Okay, final question. And then maybe I can go home. Find the magnitude of the vector, 6, -3 to the nearest tenth. All right, so what they're showing you here is, given a point, say it's here, I'm going to go to the right, 1, 2, 3, 4, 5, 6. I'm going to go down, 1, 2, 3, right? And I'm going to get this point, and I'm going to draw an arrow down here. I'm not even on a coordinate plane because it doesn't really matter where it's at. So if I look at this, what I've drawn here is a right triangle where this is 6, and really that's 3 in terms of distance. So magnitude is the same thing as distance, just a different terminology. So we can find this by doing 6 squared plus 3 squared equals c squared. We're going to get 36 plus 9 equals c squared. We're going to get 45 equals c squared. We're going to square root 45. We're going to take 45, and that's, 5 and 9, 3 and 3. So if you want to say it's 3 radical 5, you can. This again, but because it says to the nearest tenth, we can just take square root of 45 and get a decimal answer out of it. So square root of 45 equals 6.7, and that's all the answer they want is 6.7. Okay, that's it. That's all they want. That's all they care about. Okay. All right, those are 30 questions. See how long it took us to do that. It took 55 minutes. So if I can do 30 questions in 55 minutes, you guys should be able to do 18 questions in 45 minutes, I would think, right? Especially because I'm taking a whole lot of time to talk and explain and do all that kind of cool stuff, right? I think you guys have plenty of time to do what you need to on your test if you study. If you go back and you look at your lessons, if you work this stuff out, if you put forth the effort in that you need to. So, all right, let's stop there.